All right, I'm back. It's been a while, but if you're seeing this, it's probably because you saw the first Desmos video that we put out a long time ago at this point, and I've been meaning to make a new one, and I'm so excited because in this video I'm going to show you new tips and tricks that I've learned over the last few months on how to use Desmos to better work out the new digital SAT. So we'll start with the question. This is from one of the SAT tests, one of the new ones on the left here. And it looks really confusing. It says that this function is f of x equals x minus 6 times x minus 2 times x plus 6. And it says that the graph of g of x, which is a completely separate function, is the result of translating or moving this f of x graph up 4. And they say, what's the value of g of 0? Really, really tough sounding question. Maybe you know how to do it without Desmos, but we'll see how quick it is using the calculator. So, of course, we'll just type in the function exactly as we see it, and that is going to give us the picture that we see here on the right. You know, I could zoom it out if I want, and you could see it's got, 3 different x-intercepts. Cool. But we want to take that function and we want to shift it up 4, and that's going to be g. Well, guess what I can do? I could say g of x is equal to f of x, except if I want to move a function up 4, you should remember that all we have to do to the end of it is just put plus 4. Literally all we have to do. So g of x is f of x plus 4 more. And that has moved it up 4. You might not be able to tell from here, but if I go down maybe to here, for instance, you can see that the low point of both of those functions is off by, it's kind of hard to see it. For some reason, it's not letting me do it, but you could basically see that it goes up by 4, hopefully. Okay, so that's g of x. So now I could actually hide f so as to not let it confuse us. I could tap this button and it'll hide it. I don't want to delete it because g of x depends on f of x in order to get it graphed, right? But that's g of x, and it says, what's the value of g of 0? Watch what I could do. I could literally just say g of 0 equals, boom. Desmos tells us it's 76. In other words, that's the y-intercept of g. We don't have to really know why that's the case necessarily, but we could just say g of 0, and it tells us 76, and that's our answer. So really, really simple, cool way to use Desmos for this one. Let's clear it all out. Let's go to the next question. Whoa. Looks really complicated. This is number 20, so as we get further into the test, we could expect that the questions are going to be a little more difficult. This one's no different, but we want the smallest solution, so it implies that there's more than one solution. What's the smallest? Well, Desmos can do this one as well. I'm going to type in sqrt for the square root. Inside the square root, I'm going to get x minus 2 squared. That whole thing is in the square root. We could see the nice square root function there. And that's equal to, if I arrow over to get out of the square root, it equals the square root, so sqrt of inside the square root, 3x plus 34, and there it is. So we've got, let's see, at least 2 solutions. Yep, so 2 solutions there, and the smaller of the 2 of them, which is what they're asking for, would be the one on the left because it's smaller, and you can see it's not showing me when I click it, but it's obvious that it's -3. The answer here would be -3. If you didn't have Desmos for this, you could definitely do it, but you would have to be really, really good at algebra, and you would have to not make any mistakes. So this is definitely the preferred way to get to the answer. Again, -3. How about this one? An even harder question, at least in theory. It's number 27. So we have this graph of a circle. What's the length of the circle's radius? Well, we can do completing the square. You might have learned that to find this equation. We're not even going to talk about that because it's going to be more complicated than it needs to be. So let's just type in the circle's equation as it's given to us. Equals 199 over 2. All right, cool. Beautiful graph there. We could see it. Now remember, the radius is the distance from the center to the edge or the outside of the circle, right? Or half of the diameter. So it might not be obvious where the center is, and that's okay. But if I click up here, let me zoom it in a little bit so I could see this. Over here, this is the y-intercept. Don't worry about that. This here is actually the kind of like the center line that splits the circle in half. You can see it's kind of higher up. It's like at the peak of the circle. And so that is the x value left or right, of the center line, if you want to call it that, or the diameter of the circle. And if I zoom out and I go down here, how can I fit this? There we go. So this part here and this part here, those 2 points are on the center, on the diameter. So if we could find their distance, then we can find the distance of the radius as well, right? So watch what Desmos can do. You can eyeball it, or you can figure it out, right? We're going from a height of 9.5 to a height of negative 10.5. So what's that distance? Well, it's 20. I just did that in my head, and you might know how to do that as well. But what Desmos can do is you could type in distance, and then you could put in parentheses the 2 points. So the 2 points were negative 0.5 comma 9.5. I think that was the top point up here. Yep, negative 0.5 comma 9.5. And then comma, the other point within that same parentheses, it was negative 0.5 comma negative 10.5. Now if you type that in right, you'll see that Desmos automatically tells you the distance between those points is 20, but that's the diameter. It's the distance from one edge of the circle to the other through the center. So what's the radius? It's just half of 20. So the answer for this would be 10. Okay, that's a little complicated. Rewatch this part of the video if you need to see how we did that. But remember that Desmos can find the distance between 2 points if you just put the 2 points in their parentheses within the parentheses from the distance. Does that make sense? So let me show you again what I mean. I could take out these points that we used, and within those parentheses, so in the distance formula in Desmos, I could type in 2 other points in parentheses. Let's say 3, 4, and then maybe 5, 9. Okay, I picked random points and they have a decimal distance. But that's how you would do the distance in Desmos. Okay, that's another good use of the calculator. Let's keep going. Another question. Ooh, I like this one because we haven't really talked about how Desmos can be used for a question like this before. So this might look familiar because we just saw a question that had f of x equaling 3 parentheses like this, but it's not really related to it at all. But this is a cubic. We'll see it when we graph it, that it's a cubic function, and whatever, it has 3 x-intercepts. But they don't really care about that. They say that f is the function given. Which table of values represents y equals f of x minus 3? So this function has a certain table associated with it, but we want the table that goes with this function minus 3. So how could we do this? Well, we could take this function here, and what we could do is we could minus 3. So remember we said before that we can just say, f of x minus 3. We could even name a new function, g of x, like we did before, equals f of x minus 3. Okay, so it did what we did last time. It shifted that graph down 3. I'm going to hide f for now because we don't need it anymore. And the question is, which of these tables represents this function? So I think what Desmos can do here, is if I click this little gear here, settings or edit list it says, if I click that, see how there's this table that pops up over G? Click that, create table, and look, it automatically gives you a table of points that go with this function G, which remember we just named it G, but it's the function they're asking us about. So we want, look, all the x values are -6, -5, and 4. -6, -5, and 4. So what are the x values that, or what are the y values that go with those 3 x values? We could actually type them into the table ourselves. We need an x value of -6. Ooh, it has a y value, or a g of x value, that's the same thing, of -3. What about for -5? Oh, it's also -3. And what about an x value of 4? Oh, also -3. So the table, if you just look here, -6, -3, -5, -3, and 4, -3, it's this one right here in answer B. That would be our answer. So once again, if I get rid of this table, any function I have in Desmos, if I click this little gear and click the table, it'll give me a table associated with that function. And then from there, if I want specific x values, maybe from the answers that I'm looking at, I could type them in. If I wanted an x value of 99, there's my g of x value, my function value. It's a huge number, but they give it to me, which is really cool. Okay, clear this out. I think there might be one more question we've got, and it's this one, which is one of the hardest on this section that I pulled it from. And we have a table this time, and it says that for line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating. There's a theme here, right? Translating all these functions in Desmos. So line K is the result of translating line H down 5 units in the xy plane. What's the x-intercept of line K? So we want the x-intercept of the translated down 5 units graph. First of all, in Desmos, what we're going to do is we're going to go to this little plus sign. We're going to add in a table. Okay, and we're going to add in the same table we see here. 18, tab over, 130, hit the tab button, 23, 160, tab down, 26, 178. Okay, that's the table. If you click this magnifying glass, it'll zoom it out so that you could see all the points. One of them's hidden, I think, because of my face down here, but there's the 3 points. You could see they line up. Question is, what line goes through them? Desmos can do it so easily. Watch this. Click a new spot down here and type in y and then hit shift minus, and it'll go down to that little subscript. I'll do that again. Shift minus, and you can see it jump down to the little under thing under y, and I can just hit 1. So y sub 1. Then I'm going to hit the arrow over to get back to the normal height. And then I'm going to type in shift and hit the key to the left of 1, which gives me the approximately equal to thing. And then I'm going to say y1 or y sub 1 is approximately m x sub 1. I did that the same way. Tab over, plus b, or arrow over, and then plus b. That should look familiar. That's the equation of a line, y equals mx plus b. Except I'm using y1 and x1 because that's the name of the x and the y's in the table. And then I'm not using an equal sign because I'm allowing Desmos to approximate the data, if that makes sense. And look what Desmos can do. It gives you the m and the b values for the equation of the line through these points. It literally told you the equation of the line is 6x plus 22, right? mx plus b, so 6x plus 22. And now I don't need any of this stuff anymore. I'm going to clear it out, and I'm going to just type in y equals 6x plus 22. Okay, it's a good thing I remembered what it told me. That is the equation of line H. Line K, it says, is found by translating this down 5. Okay, how did we translate before? We took the function. I'm just going to copy it again. But at the very end, if we want to move it down 5, I literally just type in minus 5. Okay, and you might look at that and say, oh, it's really 6x plus 17. Sure, same thing. But see that it shifted the purple line down 5. And what are we looking for? The x-intercept of that new line, line K. So I'm going to hide the purple one so we don't get distracted by it. I'm going to go to the home thing. And now we want the x-intercept of that black line. What is it? Oh, it's a messy decimal, negative 2.833. Which of those is the answer? I don't see any decimals. Well, we can just type in each of these answers into Desmos till the fraction matches that decimal. Okay. In fact, there's another way around it too. If I type in negative 2.833 and I type in this, hit that fraction button, that isn't any of the answers, but you probably recognize that this decimal, 0.833, it's probably going to go on forever. So watch what I could do. Just hit a bunch of other 3s in there. And look what it says. Automatically, it's negative 17 over 6. Answer is D. See it down there in the answer. If you didn't do it that way, what I said we could do is just type in each of the 4 answers. So if I type in negative 26 divided by 3, that's negative 8.67. Remember, we're trying to get it to match this x-intercept of negative 2.8. So with that, I would cross off A and just do the same thing with B and C, and eventually with D, and I would find that it would work there, because if I type in D, we already know it works. There's that same number, negative 2.83, and D would be the answer. So that's all the ones that we were going to go through in this video. If this is helpful and a lot of people like this, I'll probably make another one, part 3. But hopefully that's beneficial to you. Use all these strategies. Every time I look more at this test, I can't believe how many questions Desmos can be used on. And I really can't believe that they allow this calculator because of how helpful and useful it is and how quick it's able to solve a lot of these questions. So Let us know if there's any other question types you want to see. If I made any mistakes, it happens, let me know. Or if there's a thing that I said that maybe you could clarify, share it in the comments. Like this video, share it with your friends, and we'll see you next time. Thanks.